Imagine stepping outside right now and jumping, except this time,
No! What is happening to me?
you don't come back down, not for a while anyway. Buildings around you stretch twice as high as anything on Earth today. Cars roll past, almost weightless. This isn't a dream. This is what life would actually look like if gravity on Earth suddenly became 10 times weaker. Sounds fun, right? Floating around, jumping over buildings, feeling superhuman. But here's the thing. This isn't the fun, floating video you're picturing, because the deeper we go, the more everything starts falling apart. Let's find out what would really happen. Before we break anything, let's quickly understand what gravity actually is. Gravity is simply mass pulling on mass. It's the reason you stay on the ground instead of drifting away. It's the reason the moon orbits Earth and Earth orbits the sun. Now, for comparison,
Lunar gravity is just 1/6 of Earth's. One small step sends you soaring into the vacuum.
but today we're not talking about 6 times weaker. We're talking about 10. Weaker than the moon. Weaker than anywhere humans have ever tried to survive long term. And that one detail changes almost everything you're about to see. So let's start with the very first second gravity changes. Hour 1. The world feels like a playground. The moment gravity drops, your body feels it instantly. Walking suddenly feels like bouncing. A normal jump doesn't lift you a few centimeters anymore. It launches you meters into the air. Objects around you fall in slow motion, drifting down like they're underwater, except there's no water at all. Sports become unrecognizable. A basketball player dunks from half court. A soccer ball, kicked normally, sails clean over the stadium. For a few minutes, it feels like the best day of your life. But your body wasn't built for this world, and it's about to start showing, because the same force that just let you jump over a house is about to come after you from the inside. What happens to your body? Your bones and muscles evolved under constant gravity. Every step you've ever taken has quietly told your skeleton, stay strong, you need this. Take that pressure away, and your body starts believing it doesn't need to be strong anymore. We already know what happens next because we've seen it before. Astronauts living in low gravity for months lose bone density and muscle mass at an alarming rate. Now imagine that happening to every single person on Earth at the same time, permanently. Your heart is affected too. It's used to pumping blood against gravity's pull. Suddenly, blood shifts upward too easily. Astronauts call this puffy face syndrome. On Earth, at this scale, it would mean millions of people dealing with dizziness, fluid imbalances, and blurred vision within days. So here's the price of jumping over a house. Your own body slowly starts falling apart from the inside. And while all of this chaos plays out on the ground, something even bigger is happening above it. Something almost no one thinks to ask about. The atmosphere starts slipping away. Here's the twist most gravity videos never get to. Gravity isn't just what holds you to the ground. It's what holds our entire atmosphere close to the planet. Air molecules are constantly moving, and gravity is the invisible leash keeping them from drifting into space. Weaken that leash enough, and the atmosphere doesn't just get a little thinner, it starts leaking away. We've actually watched this happen before, just not on Earth. Mars, with gravity far weaker than ours, lost most of its atmosphere over hundreds of millions of years. Now, at 10 times weaker gravity, Earth's atmosphere wouldn't take hundreds of millions of years to thin out. It would happen dramatically faster than any civilization could realistically adapt to. The floating, jumping superhero fantasy from the start of this video is quietly turning into a countdown. And the sky isn't the only thing losing its rules. The ocean is too. Oceans, tides, and weather unravel. Atmospheric pressure depends heavily on gravity. Change gravity, and weather patterns change with it. Storm systems could grow larger, slower, and far less predictable. Meanwhile, tides, driven by the gravitational relationship between Earth and the Moon, start behaving strangely as Earth's own gravitational grip shifts. Coastlines that have followed the same tidal rhythm for thousands of years suddenly stop making sense. Even the sky and the sea no longer follow the patterns humanity has trusted for its entire existence. At this point, you might be wondering something bigger. If Earth's gravity gets weaker, does that mean Earth itself starts drifting away from the Sun? Could Earth even stay in orbit? Here's an important clarification, because this is where a lot of people get it wrong. An object's orbit depends on its mass, not the strength of gravity felt on its surface. If Earth's surface gravity changed, but Earth's actual mass stayed the same, our planet's orbit around the Sun would remain completely intact. The Moon would still circle us. We would still circle the Sun. The chaos in this scenario isn't cosmic, it's local. It's happening to us on the surface, not to the planet's place in space. So what would actually happen if gravity on Earth became 10 times weaker? Not a fun floating fantasy, not an easy superhero upgrade. At first, yes, jumping over buildings and dunking from half-court feels incredible. But underneath that excitement, your bones weaken, your heart struggles. Buildings grow impossibly tall, but the ground beneath them turns dangerous. And slowly, quietly, the atmosphere that keeps every living thing alive begins slipping away into space. That first jump at the beginning of this video, the one that sent you flying into the air, it was never really about gravity becoming weaker. It was about discovering just how much of life on Earth secretly depends on gravity being exactly as strong as it already is. If one invisible force is quietly holding together your bones, your buildings, your ocean tides, and the very air you're breathing right now, what does that tell you about how fragile normal really is?